Hello students, in previous lecture we have studied about the preparation methods of alkanes. Alkanes are prepared from unsaturated hydrocarbons, that is alkenes and alkynes, by the reduction of alkenes and alkynes using different reducing agents like ranitidine, platinum, palladium. At particular condition they are converted into alkanes, as well as alkanes are obtained from alkyl halide. In wood synthesis, alkyl halides when treated with sodium metal they are converted it into alkanes, and alkyl halide also converted into alkanes by reduction process using suitable reducing agents. Today we are going to study about the few physical properties and chemical properties and their uses. First of all, we are going to discussing on physical properties of alkanes. See here, physical properties means it is a color, nature, state, electrical conductivity, heat conductivity, density, melting point, boiling point, and solubility. All of you studied about the alkanes in previous lecture. You are aware of that. First four alkanes, that is methane, ethane, propane, butane, isobutanes are lower alkanes, and lower alkanes are in gaseous state. They are found in the nature in gaseous state. They are found in the natural gases which is found or associated with the petroleum. Then the moderate alkanes which contain carbon atom 5 to 18, these are liquid in nature, and higher alkanes which are waxy solids. These are waxy solids. That means here lower members are gaseous in nature, moderate alkanes are liquid in nature, while higher alkanes are waxy solid in nature. Then solubility of the lower alkane is nearly, they are insoluble in water or they are sparingly soluble in water. As molar mass increases, solubility also decreases. Similarly, melting point and boiling point of alkanes are less. That means these are volatile in nature. Volatile in nature. That means volatility means they have boiling point which is less than 100 degrees Celsius. That means they are volatile in nature. But as molar mass increases, their boiling point and melting point increases. Similarly, melting point and boiling point is also depends upon the intermolecular forces present in the alkanes. The intermolecular force which is present in alkanes, that are van der Waals forces. Van der Waals forces, or these are also known as London forces or dispersion forces. Dispersion forces. See here, the van der Waals forces which is present in the alkanes, because of alkanes are mostly they contains carbon-carbon single bond as well as carbon-hydrogen single bond. Then that means they are saturated hydrocarbons, and the hydrocarbon alkenes and alkynes, they are generally non-polar in nature. Non-polar covalently bonded molecules. Therefore, they possesses van der Waals forces or dispersion forces in it. As the van der Waals forces present in the normal chain alkanes and the van der Waals forces present in the branched chain alkanes having similar mass. The comparison between the intermolecular forces between branched alkanes and normal alkanes, that is, see here, if the alkane is normal chain alkane, that is, for example, N-pentane, which having straight chain structure, and the branched chain alkane, that is neopentane, that is branched chain alkane is neopentane or isopentane. See here, the branched chain alkane which having a less surface area, therefore they possess weak van der Waals forces. That means the van der Waals forces in alkanes are weaker than the van der Waals forces present in normal chain alkane. That means the van der Waals forces or dispersion forces in normal alkanes or N-pentane is greater because of larger surface area. Therefore, boiling point of N-pentane, normal chain, that is straight chain pentane, straight chain alkanes, is high than the branched alkanes having nearly the same molar mass. That means here N-pentane has high boiling point than the branched alkane, that is neopentane. It is because of van der Waals forces, the strength of van der Waals forces present in the alkanes. That is the about the physical properties of alkanes. Then we are going to study about chemical properties of alkanes. See here, the alkane which containing carbon-carbon single bond as well as carbon-hydrogen single bond. Therefore, they are non-polar covalently bonded molecule. Therefore, these alkanes preferentially undergoes substitution type of reaction. Substitution type of reactions takes place in alkane instead of addition reactions. That means generally alkanes shows substitution type of reactions. That means we are going to studying about the few substitution reactions takes place in alkanes. Generally, alkanes are less reactive towards acid, base and reducing agents, oxidizing agents. That means as they have less reactivity, they are known as paraffins. Paraffins means they have param affinity. Param affinity means, param means less, affinity means reactivity. They have less reactivity towards few chemicals, that is acid, base or reducing agent or oxidizing agents. Then and alkanes undergoes preferentially substitution type of reaction. Therefore, we will study the few chemical properties, few substitution type of reactions takes place in alkane. First of all, halogenation of alkanes. Halogenation of alkanes. Halogenation of alkanes, that is substitution of hydrogen atom of alkane by halo group, that is X group, is called as halogenation. Generally X group, halogen groups, halo groups are chloro, that is Cl, bromo, Br, iodo, I, that is chlorination, bromination and iodination. First of all, we will discussing on chlorination of alkanes. That is first member methane, which undergoes chlorination in presence of UV rays. Whenever chlorination takes place, UV rays are required or responsible to carry out the process chlorination. And here the substitution reaction takes place. Hydrogen of alkane replaced by chloro atom. Therefore, CH3Cl plus HCl, that is methyl chloride formation takes place. But here substitution of one hydrogen by one chloro atom takes place, but there are 4 hydrogen atoms present in methane. Therefore, the process continues till all the hydrogen of alkanes are replaced by chloro atom, and the process that is continuous, that is CH3Cl plus Cl2 in presence of UV rays. It gives CH2Cl2 plus HCl, that is methylene chloride. Methylene chloride. Methyl chloride undergoes chlorination, it gives methylene chloride. Further, methylene chloride undergoes chlorination in presence of UV rays. It converted into CHCl3, that is chloroform plus HCl. And finally, chloroform undergoes chlorination in presence of UV rays to gives carbon tetra chloride, carbon tetra chloride. Here the chlorination of methane takes place in 4 steps, and the mixture of methyl chloride, that is alkyl halide, methylene dichloride, chloroform and carbon tetrachloride formation takes place. Here, if methane is used in excess amount, then here methyl chloride is the major product, and if chlorine is used in excess amount, then carbon tetrachloride is a major product. That means if we want to produce only methyl chloride, then excess methane have to used to get more production of alkyl halide, that is methyl chloride. Similarly, chlorination of ethane also takes place in presence of UV rays, that is CH3 plus Cl2 in presence of UV rays. Using ethane in excess amount, then it gives CH3CH2Cl, that is ethyl chloride as a major product. And if the chlorination of propane, which undergoes here, then chlorination of propane, which converted it into two different products in presence of UV rays. Here substitution of hydrogen of primary carbon atom takes place, and it gives N-propyl chloride, that is primary alkyl halide. And if substitution of hydrogen of secondary carbon atom takes place, then it gives CH3CHCl, that is isopropyl chloride, which is secondary alkyl halide, propyl chloride, and isopropyl chloride formation takes place. Here percentage of N-propyl chloride is about 45%, and isopropyl chloride is 55%. That means here the major product is secondary alkyl halide, that is isopropyl chloride. Similarly, here we can obtain the different types of alkyl halides when the chlorination of here branched alkane takes place. Then CH3, CH, CH3, CH3. Here chlorination of isobutane takes place in presence of UV rays. Then here there are also formation of two different products by substituting one hydrogen of primary carbon atom to gives primary alkyl halide, that is isobutyl chloride, which is primary alkyl halide, and the hydrogen atom of tertiary carbon atom when replaced, it gives tertiary alkyl halide, that is tertiary butyl chloride, and tertiary butyl chloride is the major product. Similarly, second one, that is bromination of alkanes. Here bromination of alkane also takes place in presence of UV rays. For example, CH3, that is ethane, undergoes bromination to gives ethyl bromide, and here bromination takes place in presence of UV rays. If bromination of N-butane when carried out, then here two different products are of two different alkyl halides are also obtained here by replacing one hydrogen of primary carbon atom. It gives N-butyl bromide, that is primary alkyl halide, N-butyl bromide, and when hydrogen of secondary carbon atom replaced, then secondary butyl bromide formation takes place. Secondary butyl bromide, which is a major product, and here the secondary butyl bromide which is obtained here, that is of nearly 98%, which is a major product, and here 2% primary alkyl halide, that is N-butyl bromide formation takes place. Similarly, if propane undergoes bromination in presence of UV rays, it gives two different alkyl halides, that is primary alkyl halide and secondary alkyl halide, that is secondary alkyl halide isopropyl bromide formation takes place, and N-propyl bromide formation takes place, which is a minor product. here 3% of N-propyl bromide formation takes place, while 97% of isopropyl bromide, that is secondary alkyl halide formation takes place. Similarly, bromination of isobutane takes place to gives two different types of alkyl halides in presence of UV rays to gives primary alkyl bromide, that is isobutyl bromide, that is primary alkyl halide, and when hydrogen of tertiary carbon atom is replaced, it gives tertiary butyl bromide, that is tertiary butyl bromide obtained here is a major product which is 99% is formed, while primary alkyl halide is obtained here is 1% formed. That is about the halogenation of alkane. That means generally alkanes undergoes chlorination as well as bromination. Then the next chemical property of alkane, that is combustion of alkane. Combustion of alkanes. Then what is combustion? Combustion means burning, or it is a oxidation of alkanes. As alkanes are volatile in nature, therefore they act as a good fuel, and on burning they produces heat energy, and generally alkanes are volatile in nature. As they are a good fuel, they converted into heat energy. After combustion, after burning of any alkane, it undergoes complete oxidation. After burning, it undergoes complete oxidation. And when any organic compound, when undergoes burning or combustion, it undergoes complete oxidation to gives carbon dioxide and water vapors. That means here methane undergoes oxidation, oxygen from excess air is used to convert it into carbon dioxide and water molecule. Here two oxygen molecules reacts with methane, which is gaseous in nature. It burns, or it undergoes complete oxidation to convert it into carbon dioxide and water vapors, which is in gaseous state. That means any alkane undergoes combustion to gives it into carbon dioxide and water formation takes place. Similarly, butane, CH3, CH2, CH2, CH3. N-butane, when undergoes oxidation or burning, it converted it into 4 molecules of carbon dioxide with a liberation of water molecule. That means here 8 plus 5 oxygen, that is 13 oxygen should require. That means 13 upon 2 molecules of oxygen from air is required to convert it into oxidation and converted it into carbon dioxide and water vapors. Then see here one more property of alkane, that is pyrolysis. Pyrolysis means here, see here burning of alkane takes place in presence of excess air and complete oxidation takes place. But when higher alkanes like hexane, C6H12, that is hexane, when heated at 773 Kelvin and in absence of air, it converted into different products. That means here the carbon which containing, that is covalent bonding present in carbon atom. Here carbon-carbon covalent bond breaking takes place, as well as carbon-hydrogen bond breaking takes place because of oxidation of alkane. And when carbon-hydrogen bonding breaking takes place, it liberates hydrogen gas, and it converted it into alkene, that is C6H12, that is hexene formation takes place with liberation of hydrogen gas. As well as here when carbon-carbon bond breaking takes place, then it gives different types of alkenes, that is CH4 plus pentene C5H10, that is here pentene, and methane alkane, that is lower alkane formation takes place, as well as here C3H6, that is propene formation takes place, and C3H8, that is propane. That means there is a mixture of different alkenes as well as hydrogen formation takes place due to the breaking of carbon-carbon covalent bond or breaking of carbon-hydrogen covalent bond takes place. And it is because of the condition used here, that is at 773 Kelvin in absence of air, incomplete burning, incomplete oxidation takes place. Incomplete oxidation of alkane takes place to give the mixture of different types of alkenes and lower alkanes as well as hydrogen gas formation takes place. And last one method or chemical property of alkane is a reforming reaction. Reforming reaction, or it is also known as aromatization process. Reforming or aromatization process. For example, hexane, that is N-hexane. N-hexane, that is CH3, CH2, 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 CH3, that is normal chain, straight chain alkane. When it is heated at about 773 Kelvin, but in presence of here chromium oxide, that is CrO3, or different oxidizing agent like vanadium pentoxide, then here N-hexane is converted it into, that is benzene. Benzene formation takes place by removal of hydrogen from N-hexane to convert it into benzene. That means here aromatic compound formation takes place from alkane when it is heated at 773 Kelvin, and chromium oxide CrO3 and vanadium pentoxide, then benzene, which is aromatic compound formation takes place, and open chain alkanes are converted into ring chain structures. Therefore these are known as reforming, and here aromatic compound formation takes place, therefore it is known as aromatization. But this process takes place at a particular condition of using particular oxidizing agent. Then this type of reactions are used in the preparation of gasoline. Gasoline, which is used as a fuel, or it is used as a automobile fuel, which is used in the vehicles. Then that is about the chemical properties of alkanes. And lastly, we have to discussing on the uses of alkanes. See here, as alkanes are volatile in nature, therefore they are good fuel. They are good fuel which on burning gives heat energy. What is fuel? These are the substance on burning which provides heat energy. Therefore these are used as a fuel, that is domestic fuel as well as automobile fuel. That means here lower members of alkanes, that is lower alkanes, that is methane, ethane, propane, butane and isobutane. These alkanes are used in LPG cylinder. LPG, liquefied petroleum gas, that is liquefied petroleum gas. Petroleum gases means natural alkanes, and these natural gases which are lower alkanes, which is liquidified and filled into the cylinder, that is LPG cylinder, which is used as a domestic fuel, as well as the CNG, compressed natural gas. That means when these natural gases undergoes compression or condensed, these compressed natural gas are used as a automobile fuels. That means these are used in vehicles as a energy production. Similarly, alkanes, that is moderate alkanes, which is liquid in nature, which are petrol, diesel, gasoline, are used as a automobile fuel used in the vehicles, as well as these are used as a fuel for machinery or used in the different types of machinery, working of machinery. One more application of alkane, that is alkane when burnt completely, it produces carbon particles. That means after burning it gives carbon particles, because the main constituent of hydrocarbon is carbon. Therefore these carbon particles are used in the ink preparation, and that is used in printing ink, as well as alkanes are good sources of, these are good sources of hydrogen. Therefore they are act as a reducing agent, or for the production of hydrogen alkanes are used here. As higher alkanes are waxy solids, higher alkanes are waxy solids. Therefore these are used for the preparation of candles, as well as in the soap formation. And that is about the alkanes. Thank you.